talk music and artificial intelligence, because that's how I describe my research. It really is the intersection of music and artificial intelligence. But something I'm really excited about now is this a huge chunk of my dissertation has been in creating this program that is aimed to help amateur musicians have the ability or be more able to compose music on their own, because I think that really is an important thing for people to be able to experience. But because of the way that I designed the system, it can actually tell us, shed some light on some music appreciation issues. And so a question that I'm sure a lot of us have asked ourselves is, really, what is it that we appreciate in music? It has this ability to convey such emotion. But what is it that we really do appreciate? We see this guy. In art, architecture, and even human beauty, you see that we appreciate things like symmetry, variation, and repetition on a theme. So it makes sense that we would appreciate these in music as well. And so the idea of this talk, and really I suppose, part of my work, is that a minimalist approach to music generation can help us derive some qualities or derive things from music appreciation, or figure out why we appreciate things in music. So, as I just said, I've previously developed such an approach. And sort of the outline for the talk, I tried to keep it not too academic, but not boring. This minimalist approach is called functional scaffolding for musical composition. And the thing you can play with is the implementation is called MaestroGenesis. It's unfortunately only available for Windows right now, but you can download that at MaestroGenesis.org. I'll show you some example musical outputs from the program, and then talk about what I think it means for music appreciation. So the main idea of functional scaffolding is that there exist inherent mathematical properties of music. When you think about music, at its core, it is repeating patterns. And so if you take that one step further, okay, well, if music is repeating patterns of pitches and durations over time, I can look at music as a function of time. And so when you do that, if you take your favorite popular piece, say it has a vocal part, a guitar part, a bass part, and a drum part, each one of those is a function of time. And when you listen to this piece, you realize that the vocal part really complements the guitar part at certain points, or the guitar part complements the bass part. They sound good together. They're not only functions of time, but they're also functions of each other. And so more formally, here you see this idea of how we would generate a computer accompaniment for a human piece. So my pointer's dead, so hopefully you can see it. There we go. This human on the keyboard is always indicating that it's human composed. And this computer up here is always indicating that it's computer composed. And so to take this idea of functional relationships in music, here we have this F of T, or a human scaffold. In this case, it happens to be a few measures of Scarborough Fair, which was, probably most people know it, but it was popularized by Simon and Garfunkel, but it's an old folk song, so I don't have to fight for rights to publish anything like that. And up here is a desirable melodic pattern. It's something that the computer creates. And the idea of functional the idea of MaestroGenesis, let's say, which is the program that FSNC has led me to create, is how can we find this G of T, how can we find this accompaniment given an initial human scaffold F of T? So basically, we have a human piece of music. Is there a way that we can find a computer-generated accompaniment, or to make it easier with this idea of functional scaffolding? And as it turns out, there is. There is an easier way than looking for G of T alone, which is hard in a computer. You have to give it a lot of, if you think about it, if you were going to have a computer-composed music, you'd have to start with a ton of music. How many people, do most people here play instruments of some kind? How about this? Does anybody compose? So we have at least one, but you can at least imagine, or most people can imagine, if you're going to get a computer to create music, you're like, okay, I know all this music theory. Why don't I tell the computer, and the computer can create it? But what we're doing with this research really is saying, all we know is an existing piece of music. Can we use functions to create an accompaniment? And so here, all this is for computer science people is a artificial neural network. But from your algebra classes or your pre-calculus classes, this is just function composition. So what I'm saying is that this helper transformation function that we saw here, that relates the scaffold to the computer-generated accompaniment, is represented here by function composition. Does that make sense to everybody so far? I'm getting a lot of blank looks. Does anybody have any questions at this point?
Can you say that last sentence one more time?
Yeah. So here, this is, I'll go back even one more. So this is a human composition right here. This is a few measures of Scarborough Fair. We're trying to get the computer to create an accompaniment, and we're trying to do it without a ton of musical knowledge, because the more musical knowledge you put into a program like this, the more your accompaniments are going to be restricted. At some point, I'll have to say, I only really want these types of accompaniments, because musical rules overlap depending on what sorts of genres you're getting into. And so what we're trying to do is create something that could potentially make an accompaniment in any style. Hopefully, you don't, although it's cool sometimes if you're playing a jazz piece and you say, okay, well, I want this in this particular style. That's great, and there are programs that can help you do that. But how cool would it be for amateur musicians to say, well, I would like this to at least make sense, and then once you have that idea, to elaborate on it. And that's hard to do in programs that create accompaniments in particular styles. So this here is a way of generating an accompaniment for an existing piece of music without using any music theory. This is math theory on some level. These are just different, you can see these are different functions here, and they just sort of all, for lack of a better word, add up together. Function composition is just sort of piling functions on top of each other to get an accompaniment. So, in other words, this is a random function that creates an accompaniment.
What is the function based on? Is it based on a note, or is it based on several notes? What is the sound?
That's a great question. And I'll get to that in more detail, but and I have representation slides at the end, which I can show you too. But it's based on the eighth note coming in. So it goes over time. Over time, it looks at particular eighth notes, and it's not based on music theory itself, but functions that have been selected through genetic algorithms.
It's sampling, basically. It's sampling and reading.
Yes, you got it. And so, to get kind of to your question too, so how do we find these functions, or what's special about the functions, and can you put any function in? And while you can do this with a lot of different functions, the way that we find them is through something called interactive evolutionary computation. Evolved through Green, you can see up here. But the idea, is anybody familiar with interactive evolutionary computation? A little bit? So genetic algorithms are based on this idea, kind of how we can create new things from a population of existing things. So here, we've done this with animals as humans. We've started with, say, a population of wolves and created this wide variety of different crazy-looking dog breeds on the right. And the way that we did that was just through selecting for particular appealing traits. If the dog was nice, or the wolf was nice, we're like, okay, well, why don't you breed that wolf and hope that the temperament of the wolves afterwards are great. Clearly, these ones look like they've been selected for different visual characteristics, like some sort of dreadlock thing on a dog and a muffin down here. But they all started off, which is crazy, they all started off as something like the wolf on the left-hand side of the screen. And so we're implementing that with these functions, these transformation functions that are creating musical accompaniment in the computer. Here's another like a more, so that gives you an idea of what evolutionary computation is in the physical world. But it's been done in computers before. Actually, Richard Dawkins first talked about it in his book, The Blind Watchmaker. But here you see this parent butterfly here, which may be something like the wolf that we just talked about. And this parent butterfly has a bunch of different children. Well, you pick a particular child that you may like. Here, I chose this one because it has a smaller black body and black wings. You notice that that's different than the rest of these guys. And so that becomes the parent of the next generation, and these children all inherit similar characteristics. This one has a little bit of a darker pink thing on its wing. You notice you don't see that a lot in the other children, so I picked that one. And then most of these other ones over here have this darker pink thing in its wing. And so you can get a wide, like the dogs, where we saw a wide variety of different dog breeds, you can get a wide variety of pictures just through this process of selection.
So those were all programmatic visual examples of using programming and computer science to read things and visually select.
Exactly.
Okay.
And so the reason, so that's how we select these particular accompaniment functions. And the reason that's important is because exactly that's what we're doing with MaestroGenesis, which is the program that I've been working on. And so hopefully you can all see this. But each one of these squares here represents an accompaniment, a particular accompaniment. So you can see up here the numbers sort of can help you delineate, but you have 1, 3, 7, and so each one of those are represented by this transform function, and each one of these can be played in the program by clicking on this play button here that's highlighted. And so if you get a chance to download it, I'll show you, I have to switch operating systems to show you the program, because it unfortunately runs in Windows, but anyway, you hit this thumbs up button over here if you happen to like it, because remember you have to tell somebody, you have to tell the program that you like this trait in this individual. So I hit play to listen to it. I can visually inspect it through a notation that's not standard music notation but makes sense. The length of the note represents part of its duration. So the longer the note, the longer that line, the longer the note. The higher the bar, the higher the note. The idea being to help amateur musicians. You hit the like button if you happen to like the traits. You hit this evolve button over here to create this population of a bunch of different children that inherit some of the characteristics of the original accompaniment. And so I'm going to show you one example that we did, which was pretty cool, because it showed that this process of searching, this search process, which is important in computer science, was helping us get to a good space of musical accompaniments. And it shows you maybe what you can encounter using MaestroGenesis. So what I'm going to play for you first is the human composition. So this was sequenced by a guy named Barry Taylor, and it was sequenced originally without accompaniment. You get an idea. And right up here we see generations 1, 6, and 12 so it took 12 iterations of looking through children to finally get an accompaniment that I really liked. And on the bottom here is what went into the program to get those individuals. So I'm going to play, first generations can sound awesome, and we have actually published first generations with the program, but I'll go ahead and play this first generation for you. It's not the best. Here it over-articulates. So can everybody hear which one's the accompaniment here? Sounds a little less natural.
Over-articulating meaning like so many fast notes that
Right.
it really is too much in your face.
Right. Nobody really wants, I mean, some people I'm sure want that on their accompaniments, but if you're trying to make more popular sounding music, you might not want something like that. On the next generation that I'm showing, which is generation 6, so I've presumably looked through maybe 7 or 8 individuals using this program to get to generation 6. And here, this one actually gets very close to the end. It starts to sound good, but there's something harmonically stale about it. It's better than the last one, though. It doesn't make all those extra notes that it shouldn't. Here how it kind of just goes from one note to the next, or back down again. And finally, we have this last one, where this problem is rectified. Now, something to keep in mind is that, again, apart from key, this program has no knowledge of music theory. It doesn't know what a fifth is, it doesn't know where fifths should go, it doesn't know anything about music theory apart from key and what is going in. So these parts, the original piano, harpsichord 1 and harpsichord 2 go in, and these notes come out. But you notice how it still follows the contours of the song. And so what's cool about this is that people, although this study doesn't, let's see, here we go. This piece right here was without significance, or was rated about the same, how about that, as the original piece that was created without accompaniment. So that tells us that, great, we've gotten to a space where we're starting to make things that sound pretty human. Here's another example of a song that was created with the program. It's called Nancy Whiskey. I'll play for you the scaffold. And the scaffold again is the human accompaniment. This is or the human piece rather, how they created accompaniment. A lot, but Michael often hates it. Here you can hear the accompaniment that goes well with it. Alright. And this is the part that gets exciting because here you can see, hopefully on this left-hand side, likelihood of being computer generated. So the higher it is, kind of the less excited you get about the results. If it's because we did a musical Turing test, so we're asking people, how likely is this that it was generated by a computer? And if you notice here, the lowest, so lower is better in this case because we're hoping that people can't tell that these accompaniments are generated with a computer. That backgirls them in, so that generation 12 of what I showed you actually was judged more human than some of the fully human composed pieces, which are these 2 in green right here. So the 2 in purple were partially composed by a computer, the 2 in green were only composed by a human. So without the computer generated accompaniments. So here's a cool one too for Scarborough Fair. I'll play for you the polyphonic scaffold, the piece that a human has created, and then add on the accompaniment that was generated with MaestroGenesis. hear this accompaniment. And you notice when the song changes, again, there are no musical cues apart from what the person created at the piano. We haven't said this is the A section, this is the B section, but you hear that the accompaniment still changes with the original piece. We've done cool things with Eminem or, I guess Power Rangers, I don't technically have rights to. But we've done things with Eminem, things that we can't publish. So it's not limited to just this folk music that I'm showing you. If you were to use it for your own pieces, you may find something pretty cool. But the question that I'm interested in, or part of the questions, one of the questions that I'm interested in, is how much information from that scaffold, from that human composition, is really necessary to create accompaniments. We were seeing information coming from a bunch of different instruments in a polyphonic or multi-voice scaffold. But the next step I took though was, how about we take a monophonic voicing, or if you maybe like your right hand on a piano or something, just an instrument that plays one note at a time. How about we feed that into the program, into MaestroGenesis? Again, we're looking for this helper function to find a computer-generated accompaniment. And then we take, so that's similar to what we've been doing, but you have more voices on the bottom that were human created. But then I had, oops, here we go. Then those get put into the program. My undergraduates actually did this, so I shouldn't say that I technically did this. But, and to generate that G2 up there, which you can feed in to get G3, to start creating a polyphonic accompaniment. And so this up here, yeah?
When you say feed G2 to get G3, G3 to get the next one, are you feeding all of the ones underneath to get the next one, or just the most recent one?
So there were a group of 3 undergraduates who did it in a variety of different ways. I think the ones that I'm showing you, the person fed most of the original ones into the program to get the accompaniment, but you could do it any way that you want.
Okay.
So sometimes people would feed, sometimes maybe you like G2 as a scaffold element, maybe it introduces some sort of aspect that you like, but you don't actually want to hear it, so you can, you have to do it manually, but you can turn it off in the program. So you can use G2 to generate G3, but you don't necessarily have to use G2 in your final piece. Does that answer your question?
Yeah.
So here is something that one of the undergraduates created. Up here is, you can see it's, whenever you see a human on a keyboard, it's human created. So she created this piano 1, layer 1 up here, which is just a simple monophonic melody, and used the computer, used MaestroGenesis to get all of these other parts down here. And when I play it, I get most of, like the trombone and trumpet are clearly very different from what you started with, but they still complement the piece pretty well. And it's almost hard to tell that the piece wasn't written with that in mind. I'll go ahead and play this scaffold that she wrote for you first. So that's nothing too complicated. It's just something you could, sort of get out of a keyboard as you're messing around with it. But after going through the program, she was able to create this entire piece. And again, remember to pay attention to the trombone and the trumpet. So it's like a pretty cool end for a piece that didn't have that set into it, didn't have to start with. And there, again, no music theory is built into this, so it had no knowledge of what sorts of things to do at the end.
Is it avoiding collisions with other notes?
Is it avoiding what? I'm sorry.
Avoiding collisions with other notes that are too high, things like that. Is it trying to avoid? Because some of the accompaniments were clashing, but these ones were perfectly avoiding the notes, loud notes.
The user can sort of, you can pick, I'll show you this hopefully when I get MaestroGenesis set up, but you can pick which instruments you want to use, and that will determine which octave you're in. Or if you're using it as I would use it or anybody else, if you plug it into like a digital audio workstation, you can always change it. So this user, I think, used particular instruments that she might have matched with other instruments later, but it wasn't on purpose, I don't think, other than selection. Yeah.
I came in a little bit late, but I was just curious. So you said that there's no like music theory input in here, but is it possible that maybe some of the algorithms just naturally maybe like mimic music theory, and so that's how it's happening? Because it is a very numerical process to do music. I mean, even if you don't realize that it is.
Right. No. Yeah, and that's what's really cool about it is it's not using standard music theory. So it's not using music theory as it's taught to you from school, which allows us to sort of, and it's crazy because it's still producing things that, I mean, maybe I don't want to listen to it on my iPod or whatever, but it's still producing things that I can use to help my own compositions, or it's still producing things that some people can't distinguish from between like human created and computer created.
Definitely. I don't know a lot about music theory, but it was interesting looking at the trumpet and the trombone because it's like they were creating a harmony that was low and high, and it was figuring that out. And I don't know if it was even, almost like mimicking like the rule of thirds or fifths or whatever to do that, but it almost looked like it,
Right.
So it was kind of
but yeah, which exactly like, and so it helped us to sort of take a step back from music theory because it is just this sort of once you get in it, you're in it. But it is sort of this mess of rules, and you don't typically, once you know music theory, you don't typically take a step back to really think about it computationally as much. Some people do yet.
But each stage is also being selected by a human on what appeals to their ear.
Exactly.
Okay.
So
Sorry.
go ahead.
How many generations did it take to generate?
That's a good question. I'll go back to this one. Each one of these, I can't remember, this was published a couple of years ago, but each one of these layers took between 3 and 5 generations. And so what's cool about MaestroGenesis is that you can look at the accompaniment and sort of tell maybe that certain notes are going to clash. Like, you know it's in the key of C. If you're on way too many Ds or something, then you're probably going to have a problem on some level, unless like that's what you're going for. So you only have to listen to maybe 1 or 2 out of each set of 10 that MaestroGenesis provides you. Sort of swing. I'll play this one last piece for you, and I'll switch over. I want to be able to show you the program, but this is one more piece that one of our students wrote, and so this is his monophonic. Should be his monophonic scaffold. And here is what he got out of the program. One last published result, if you will. But what we sort of saw is that these programs can help amateur musicians. You don't have to be able to read music theory. You don't have to have a particular style in mind. You can just sort of etch something out, plug it into the program, and get ideas or get pieces that you can add to your own composition. The examples I showed you illustrate how this idea of functional scaffolding works. And hopefully opens the domain of music composition to amateurs, but it's, again, freely available software online. And so, I think that might have been a lot for you guys. I don't know how much more of the theory you want to hear, but this idea, because we have gotten this super simplistic way to generate music, helps us understand more about music appreciation. It may sort of explain why we can intuitively appreciate a good riff or a jingle, is because there is this idea of a perceptible functional relationship. So maybe when we listen to a piece of music, what we're appreciating is this functional relationship, and why it may take more effort to appreciate, say, atonal music or art music, because we're not familiar with those types of functional relationships. Initially, our brain is unfamiliar with the complex representations, but over time we begin to get an idea of what to expect. And this is something I'm interested in exploring more. It's not published at this juncture, but I'm hoping to get more done on this. We know that when to break the rules is a hard question. A good musician knows when to break the rules sort of intuitively, but the insight of this theory is that a rule is well broken if you maintain that perceptible functional relationship. And while this is clearly one, this is not the only thing that leads to us appreciating a piece of music. It certainly helps us understand another aspect of it. And so that's from the slides I have prepared. Does anybody have any questions while I try to switch over? Go ahead.
Were you saying that with the first generations, they tend to be like a lot of notes, like it's like really, it's kind of going all over the place, and then as it goes further, it gets a little bit more like it narrows down the sounds and pitches that it wants to use?
That's definitely what I showed you.
Okay. Is that often what happens, or is that just what you were showing?
It really depends on what you feed into it.
Okay.
So if you feed in something that's slow, it doesn't change. If you feed in something that's slow and doesn't change a lot, then it's because it's just taking a function of that what you gave it, then it's going to be a little bit slower and not change a lot. Now, if you give it a polyphonic piece, and that polyphonic piece has parts that are slow and don't change a lot, and has parts that are fast and all over the place, it can more easily switch between the two, or it can take aspects of both of those and combine them, or it can listen to a slower part. But ultimately, it's up to the user who is selecting.
Okay. It was interesting because it almost made me think of when I compose sometimes on the piano, and I'll start off just kind of going up and down the keyboard with my fingers, messing around, and then before you know it, you start to isolate a couple like sounds that you like, but it's over a couple, attempts that you get that. So I wasn't sure if that was kind of mirroring that at all, or if it's,
cool.
Because I mean, that's, at least for me, when I play improv piano, you kind of just move all over the place, for me at least, and then, I liked how that sounded, I'm going to keep repeating that. I liked how that sounded, and then before you know it, after a couple attempts, you finally isolated something set that you want to do. So it just seemed to be almost enacting in a way that process that I've done before.
That is a really cool analogy, and I'm glad to hear you say that. You could see that relationship. It gives me faith for the program.
Amy, where are you publishing these?
You're computer science at UCF or digital media? So we're at International Conference of Computational Creativity. It's a mouthful. Evo, Muzart, Evolutionary Inspired Music, Sound Art and Design. Gecko, Genetic and Evolutionary Computation Conference. I feel like it would be Sound and Music Computing, and Computer Music Journal is our most recent one. So it's sort of in the middle between computer science and music type stuff.
I wanted to ask you briefly about the math that is used to model.
Mm-hmm.
So say you are starting with a monophonic line, and you're representing that in the program, presumably with some elements of mathematical equations or ways to kind of, like, you're given a line of music and somehow you're representing that with numbers, mm-hmm. so that it can generate the first children of the genetic algorithm, mm-hmm. so that you can then choose those and breed them.
Right.
So, without getting too into detail, which I'm sure will get over my head pretty quickly, how does that process happen? What kind of math, what kind of things do you use to kind of...
It's actually a lot more simple than it looks, I think.
Okay.
Because we don't do any sort of modeling of musical type relationships. Really what we say are, these are a set of functions that we can use. We do use functions that are handpicked for things like bilateral symmetry. So in humans, you have like this symmetrical, not everybody's, nobody's perfectly symmetrical. You have this idea of bilateral symmetry. We input, sometimes, it's not in MaestroGenesis, but this idea of a sine wave to just get this repetition. You can input these are all functions that you can choose to start from when you start building functions on top of each other. So I can take essentially what that means is I can take parts of the bilateral symmetry, and by introducing a linear function, I can get a little bit of an asymmetry. I'm not restricted to the symmetry that, the Gaussian being the bilateral symmetry was restricting me to before the linear.
Okay. So those almost become your design language in a sense, like you're introducing the idea of symmetry and the idea of repetition, and you've got almost like a musical design language that's influencing that.
Yeah, and what's cool is that the design language comes from what we saw with the images I showed. So very briefly, the butterfly that we went through just sort of illustrate what interactive evolutionary computation is, and the variety of different pictures that we got just from selecting for different traits. We saw that it worked really well in this sort of picture environment, and so that got us thinking, well, what do people like in music? And let's see, we think that, that these repetition, it's when you say it, you're like, of course, that's what you appreciate in music, repetition. little bit of variation on that repetition, and so that's how we ended up picking those functions. But that's not to say that there aren't better functions, and it's something to explore for sure.
Okay, so I missed the beginning also, but is there any part of this where you're training the algorithm what's more pleasing?
Not in a neural network sense of the word of training. We don't have a target, and we're not using that prop or anything like that. The training, if you want to look at it that way, is just through the interactive evaluations, which I can.
So it's all in like each individual melody, then you get to pick, but it's not like you can tell this program like this collection of this symmetry and this linear thing is putting these things together is pleasing. And if you do it, like can you combine, I can take any melody and then run the same set of generations against it, and it will tend to make something that people like.
Are you asking if that exists or if that theoretically exists, or
does it exist now?
It does not exist now.
Okay.
Could it exist? I think so. It's something that we'd have to program in, which brings me to this right here. I don't know if anybody was able to download it or run it because it requires Windows, but you got a quick start here. You can load your own MIDI in here, and you can load a previously saved state here of load file. And I'm going to show you quick start because I have Scarp, and you can choose between Bad Girls Lament, which is the song that I showed you, Nancy Whiskey. Actually, I showed you all three. But Scarborough Fair tends to make accompaniments that sound pretty decent. All right. So here are different accompaniments that were generated on the fly from Scarborough Fair, which, as anybody who's done demonstrations knows, is rather dangerous. So some of these you can look at and sort of tell which ones, well, you have an idea of which ones may sound decent. Like maybe this one, maybe that F sharp's going to be all right. So everybody can hear the scaffold. When I was playing the scaffold, you can hear the difference between the scaffold and the accompaniment.
Monotonic, the scaffold.
The scaffold right now is polyphonic, and the accompaniment is monophonic. So, although you see a ton of accompaniments, we're only playing with one that's sort of highlighted in yellow right here.
And can you completely isolate that? Like if you were using this?
You could, yeah. So
I see, bass track.
Yeah, there are a lot of different options. So I'll go ahead and isolate it right now. Alright, not the most complicated line, but how does it sound with the scaffold? Hopefully, like, through evolving, you can get it to, as you saw with the first song I showed you with the different generations, over evolution, I was able to get the sort of flat sounding, it's not flat in the, like, B flat sense, but to me, the best word I have to describe it is just flat, because it was just going back and forth. Whereas generation 6 of Bad Girls Lament, whereas generation 12 had more contour to it. And so over time, through training it, you can get it to develop more of a contour. So that one might be a good one to start with, but I want to check out and see if, and so I could hit like, and then I could, so like is right here, right there. So you could hit that, and then you could hit this evolve button over here. But if you want to check out other ones, because maybe, the piano gets old after a little while. And you can clearly change that if you were actually use it during compositions. You can clearly change it in your digital audio workstation through GarageBand or whatever it is you're using. But you can change it in here to help you get a better idea of what you're hearing. And maybe the harmonica sounds kind of cool with
between those two, the one you have selected.
All right. And so what you can do, by the way, is if you're scared of, well, if you'd like to save it and import it into your favorite program, you can hit save here, and it comes up with, you know, whatever MIDI I want to save it as, like test MIDI, processing, Orlando. You can hit save, and so then you have a record of the MIDI itself, what you heard, and it saves the file so you can look back into the program later and continue to evolve off of it. But I'll go ahead and hit evolve from there. So that's this button I just hit over here. You can see that the rhythm, so this first individual is always a copy of what you were evolving from, so the parent, if you will. It's a practice for genetic algorithm people called elitism. But this should always be the parent of the previous generation. So we don't have to listen to that unless we want to remember what it sounded like. So maybe this doesn't look promising, but maybe this one would be okay. You can tell, you don't have to listen to this one. You can tell that's terrible. Right.
What do the numbers represent?
So the numbers in here are their individual numbers. So there's a certain number, when we generate functions, there are a certain number of individuals that get thrown out based on representation issues, non-musical related things, but if the network has what's called recurrent, if the connections are flowing in a weird way, we'll throw it out. Sometimes if it's all silence, we'll throw it out. And so it's, you know, you can tell, like, okay, that's not going to work. So this is 1,117, 1,203. So those, right, there are a few in between.
Iteration numbers.
Right, exactly.
Did the program throw those out?
Yes, the program throws them out. The ones that are absolutely awful. And that's actually a cool point of research that we started messing around with a little bit is this idea of filtering. So maybe, because sometimes you really do want something in a particular style. That's, you know, part of what Band in a Box is so awesome at. Is like, okay, cool, I'm playing this piece. I want a backing band. I know it's, you know, a bossa piece or it's some sort of jazz piece. Like, wouldn't it be cool to have all this accompaniment? And so sometimes you do want that, and it would be cool to put that on top of what the existing framework. But that one looks a little bit like the other individual we saw. And we'll test one more before we try evolving. Any preference? That one sound okay?
Yeah.
Or do we like the previous? I forgot which one the previous one.
And I assume you can thumbs up multiple.
You can, yes. But the
Does it mix both of them?
it can mix both of them. Yes, it uses an algorithm called neuroevolution of augmented topologies, which I know is a mouthful.
That makes sense.
Okay, awesome. So it can mix both of them. It's sort of up to the genetic process itself as to whether or not it actually happens. But yeah, so which ones were better in that case? Do we tend to like more? Was it the second one?
The second one was great.
Okay.
So it basically sees it sees the evolution of these two. It's not selecting one of them, it's just seeing them as a pool of things to evolve from.
Yes, that is true, but sometimes it, like with the elitism idea, it always has that individual as a copy, and sometimes the changes are so minute that it almost looks like it's the same individual. But there's always at least one identical, sibling.
Sorry, what was the name of the algorithm?
It's called neuroevolution of augmenting topologies. And it's actually an algorithm that my advisor came up with at the University of Central Florida. didn't come up with it there. Oh boy. So that's a problem. But where was the other one? Do you guys remember? Oh, right here. I remember talking. Oh no. Was it this one?
It was at the top.
Sorry.
Most of the notes were higher. The second one.
No, I think it's something else. That one.
This one? Okay.
1547.
Alright. So then I hit evolve. And this is that first individual that we selected. Let's see if this one might sound pretty cool. So it's a little different than like it's related to the parent.
Yeah.
So when you start getting into that position where you're like, gosh, like I'm tired of hearing this, you can change the evolution settings by adjusting this mutation rate. When I'm messing with it, I typically turn it all the way up, but that has its negative aspects where if you really like something, you're gonna have to turn it back down if you would like just minor variations. But if you want to see more of the types of things the program can do, you may want to turn that back up.
So currently, is the only way to step backwards in evolution to open that saved file?
Yeah.
Okay.
So
Pick one that's really wild and different.
pick one that's wild.
Like all the way up, it's awesome.
All right, let's see. So let's pick this because we remember this one, right? And then we'll see what types of things we can get. So it should be fairly different. The first one's always going to be the same. You can see very clearly that these two are quite different from that original.
It's actually becoming flatter.
It is. Which is different. I guess it couldn't go any more over the place than it was. But it doesn't always work out that way. It really depends on what you start with as an input to the program and which individual you start selecting. So I showed you over here, if you mess with it, you can change the instrument. You click over here to get like a general category of instrument, and you can click one of these to change it to whichever particular instrument in that category you want. Here, you click the like button if you happen to like something, or the save button. You can change the key here, which is going to cause a problem if you change the key. If we have key detection working in the program, but if you potentially try to trick it, it's going to be tricked. It's not super sophisticated. It's just looking for the closest match. And so you may want to set that on your own. When you load in your own MIDI, you're like, okay, well, I know I use a lot of notes from a particular chord, but I really would like the output to be in this either major key, or you can click here and do a minor key. Something in the future we'd like to do is to have each measure maybe be able to say for each measure what key you want the measure to be in, if you want it to be different, because that may be useful on some level, or just something that would be really easy to implement that just isn't in there. Does anybody do anything with atonal type of music?
Well, I was going to ask, can you let it slip out of the key? Can you have some parameter that says you're allowed to play these notes that are not in the key
Right.
to a certain degree?
Right. That is actually implemented in the program. It was in a previous version. We tried to sort of interface-wise dumb it down, and we're looking to add that back in. We called it binning or whatever. So theoretically, yes, we've actually seen it. It's not in there right now, but it's something that we'd like to add back into it. We got there are only 2 of us working on this, which is actually cool because most PhD projects we have 1 person working on it, and it may or may not be funded. So that's why the interface is a little more polished than a lot of sorts of, than the interface would have been without my partner helping me.
It sounds better than most regular programs I've
I'll tell. Thank you. I'll tell my partner. But yeah, so that's something we'd like to add back in because a lot of people do more, especially as you said you did different installation type things, which is starting to get out on the art music side of things.
Right.
And
I certainly have friends that are well in that space.
right. That makes sense. It would be cool. And especially when you're learning, I think when you're learning art music, at least that was hard for me to start sort of getting into atonal music. And I think that something like this really could help you. And at some point, it would be awesome if we encoded different rules to be like, oh, I did this little pattern here. You may recognize that from this other stuff you were doing, and sort of help you. That's a research direction. It would be cool to use it to help learn more about atonal music, which, in short, for people who aren't familiar with it, is you can play things that aren't necessarily in a major key. So you can explore all the notes, all the chromatic notes. So you have your C's and C sharps within the same piece and the same setting, and so it sort of has a jarring feeling at first, but the more you listen to it, the more you start to understand the patterns, and as I said, as you start to understand them, you start to appreciate it a little bit more.
And you may have already said this before, but I was just wondering, like, where does it end? When you're doing like this composition piece, or like when you get to a pattern that you really like, can you keep it almost plateau it so it just stays within?
That's a really good question.
Versus, or is it like right now, is it constantly evolving? Because I could see like, oh yes, I want that. Oh no, you're evolving already. I don't want you to do that.
Right.
Just stay right there.
So right now, it's a standalone program. You can't use it in conjunction with your GarageBand or whatever.
Okay.
So you would have to hit save on the MIDI, and God willing, it saves, and you plug it into your program. So that's how you can. I think that that answers your direct question. But something else really cool you can do is if you find a pitch element of the piece that you really like, you can hit this idea called pitch evolution and continue to evolve the rhythm of what you're hearing. Or you can hit, and if for whatever reason you want to hold both of the evolution and continue evolving, you could do that. Or you could just hold the rhythm evolution if you happen to hear something you like. There's some nuances that make it, when you hold rhythm evolution, the rhythm, and just if you use it practically, the rhythm will be a little bit different because the pitch is allowed to change. And so if you have like an A eighth note, a B, well, at any rate, the pitch overrides the rhythm, so sometimes it will change a little bit. So that's another cool setting.
Okay.
Up here, I think you saw me hit the play button. It's how you play. Let's see if we can get something. What were you wanted something wildly different? I don't know. This was.
I've seen what happened in this particular case because it went for simplicity. That probably doesn't happen every time.
No, it doesn't. And actually, that simple one I picked out led to because of this mutation rate I set up here. You let it make and mutate with all these other networks. It still knows the parents, but it's able to do a lot more mating and mutating. So you see a lot more variation in what you started off with and the resulting individuals down here. And again, you can adjust the bass track volume over here. Does anybody run Windows? Or like I find 1, 2, we got a couple. So like we could use, would anybody be interested in using a program like this for their own compositions? You guys can see yourselves. So if you have any questions, the email it, you can contact me directly, or I think like our stuff is up there, our email address is up there. And it's really awesome to hear that some people are using Windows because I've definitely I've given this presentation before to a CEO of MacBooks Open, and as you can see, I have one too. But, it's really disappointing when they're like, okay, well, that's great. You can just hold on to that because I can't use it. So, thanks. Are there any more questions? Yeah?
So what is the underlying language?
C#. It was a design decision made a long time ago. And which today I wouldn't have made the same decision. This actually stems from an undergraduate project I started. So we're looking at, I think, 7 years ago. I would really, and this is Windows Presentation Foundation, which is not supported in the program that allows you to take C# and run it on other computers. So we're looking into making it multi-platform because we recognize how important that is to get any sort of use of the program.
still like, just processing for your people. What are your thoughts on actually just supporting the underlying algorithms? Not even putting it language, but actually supporting the underlying concepts over to something like the same processing or something like that.
Well, Java's not that different from C#, is it?
Java is really similar. Right now we just don't get paid enough to code it all over again. This is the step. Yeah, I mean,
Other people do it.
it's not a bad idea actually, and I may suggest that at some point.
So you have an example of the reverse of this, like you sent some of your students for doing the opposite, where they are making full composition instead of just the one part to accompany.
Starting with the multiple tracks and then generating.
Yeah, those
the
are the
same one.
first ones that I showed. They didn't, although it doesn't completely answer your question because those weren't created by the students, I suppose. But those polyphonic pieces, like the Scarborough Fair example, I mean, even what we hear here. I guess I forgot to show you guys this part, the input selection. These are all like, this is what goes in. This is a scaffold. You can hit play to hear it, and so this should play without any of the accompaniments. So this is all written by a human, and you have, this, you can't see what I'm playing on. This track up here, this first track, all of those are going in. And the accompaniment is the one voice that you hear on top of that. So, this one maybe is cool.
How hard is it to start with your own polyphonic composition and bring it in here and start generating new tracks for it? Like say you composed, 4-track thing in GarageBand, you can export it as MIDI.
Right.
You have to do it like track by track and build it up, or
No, as long as I would save it as, format 1 or whatever. I would save it so or format 0. I'd save it so that each of the tracks is separate in the MIDI file, and you can load that easily. So what that means, it's still the same MIDI file, it's just, you pick which format to save it. I don't know how many people are familiar with MIDI, but it's, as you hit one button, you hit save, and then you can load it in here.
Gotcha.
So, yeah.
not different.
No, not at all.
Cool.
Okay, so how, when you hit the button, your process is pretty fast. It's going to be able to generate lots and lots of generations. Have you ever tried doing this in real time?
It's an interesting idea, but and there are some people who use GAs in real genetic algorithms. Some people do this sort of thing in real time for sure. The problem with the way that we represent the scaffold to the computer is that you sort of need to know the full duration, you absolutely need to know the full duration of each individual note before it's going to give you something to play. So it's not, you don't have to know necessarily each note in the piece, but the program needs to know, okay, we're at the halfway point for the duration of this particular note in order to generate the accompaniment. So we're thinking about ways to sort of get around that because it would be really awesome to use in real time. But we haven't, that's a really important facet of the program and the representation that's been working so well for us. We haven't been able to overcome that yet.
Could you have an underlying beat? Could you define a window, user-definable window, where you could say this many beats before and this many beats after is what the algorithm is allowed to look at in order to generate the next block, and do that with a big enough window so that you can get that generated before your playhead gets that far? And almost do it like stanza by stanza instead of note by note.
You can always be generating accompaniment to the previous phrase.
Right.
You'd be producing a canon or something like that.
I think thinking of looking ahead at the file. What were you talking about in that light?
Doing it live, but being able to look either behind or ahead, depending on the details. I mean, yeah, there would definitely be some side effects to doing that.
But I think that would be like part of the fun is can you play?
Yeah, that'd be another one of the parameters, yeah.
Or respond to a sample in a nice way
Mm-hmm.
for the accompaniment. You were talking about finding results, the way people appreciate music earlier. And the thing that I'm obsessed about, that I don't know if you have any more insight thanks to this research, but I'm always interested in why music becomes why certain music becomes, it's really pleasing at first and becomes quickly really annoying, or why certain music sounds annoying at first and then becomes really, really obsessing over time as you understand the complexities of the rhythm or something like that.
I mean, this is just my intuition, but I think, sometimes we're in the mood for maybe less intellectually stimulating music. Like if you're running at the gym or something, you're not looking for something that's super harmonically complex, you just want to get pumped up to run. And so it's cool, you appreciate the relationships in that piece of music. You perceive them as relationships, and it's good enough, it serves its purpose, and maybe it's not something you listen to outside of it. I think that when you listen to something, you might appreciate so your next question was, or I guess your question was, okay, I'm listening to a piece, it sounds cool at first, and I'm done. I think the novelty of that relationship just gets old personally, like anything else, and it's just, okay, well, I got it now. For me, the Rolling Stones do that a lot.
So in your language, it's that I've discovered the function, and it's not normal. Like that whatever produced that rhythm is not exciting anymore. I need a more complex function, I guess. Does that make sense? Do you think that more complex music would translate into a more complex function? So you're talking about function.
Right. I see what you're saying. The function, relatively simple functions can generate, so it's the relationship between, the function represents the relationship between the input and the output, so they can sometimes sound more complex than they are, or they can sometimes sound more simple than, maybe you have this huge, 25 function network and it's playing B all the time because, the weights are set to 0 or something. But I do think it's just something we get bored with, to answer your, yeah.
Has anyone looked into this thing, that there are certain melodies that just by the nature of them get stuck in a person's head and you cannot get them out, and there is something that they trigger in the human mind that you want to whistle them and the whole thing. And has anybody in your program looked into what is that quality of that music that makes it stick in the human mind?
No, but it would be really cool to work with music cognitions to sort of integrate this idea into that, because I think that there could be some relationship.
In other words, they've done studies on what are the elements that make a hit.
Right.
And then they're trying to generate software so that you know how to actually in advance set something up to be a gold medal winner.
Right.
So you should hook up those like buttons to actual Facebook. That way you can analyze the people using it.
It would be awesome to have more examples of cool, because right now it's just things that we've done, and I can generate all these results, or whoever generates all these results for the paper. What's your question?
So when you had started, you said a main area of your focus or research is trying to find what the minimal amount of human-generated music could be. Were those examples that you gave us earlier, is that pushing the limits of what you can have in terms of the bare minimum and still have something evolve out of that that's...
Well, yes, in a way, because what we started with when I started when I started graduate school, we built up this program that allowed us to generate a monophonic accompaniment from a polyphonic scaffold. And we're like, cool, that's great, we can do that, but not all amateur musicians can compose these complementary parts. So I think most people can set their hand on a keyboard. So let's see if that's enough information. If my right hand on a keyboard is enough information to generate an accompaniment. And we're like, cool, it actually was after we went through all these different processes. The thing that I proposed, which I'm trying to get done before I defend in August, or around a little bit before then, is this idea of sectioning music. So wouldn't it be cool if I could generate a function for an A section? And maybe once I know perhaps I'm in the B section, I can start sending in an extra input per se and get something that sounds similar to the A section, but actually is different enough to be either A prime or a complete B section or something like that. So that next step is something that we don't have results from that experiment round yet, but I am really interested in what it means for music theory as well as just, what it'd be cool to do.
So is that kind of like saying you could write the verse and it would write the chorus?
Right. That's exactly what that would mean.
Okay.
So theoretically, that would be less than the examples that you gave.
That would be less, yeah.
Less, okay.
Yeah. Because right now you saw that you needed the entire piece to get anything. Like it goes from start to finish. I was looking to see, I'd have to, I guess it's right here. Although I think the person who asked me this. But this is or I guess you asked the initial thing too. This is, I don't know what to see it, but this is the representation. This is how we get stuff to come out like this. This is the rhythm input here, and this is the pitch input. And when it's outputting, so that's, I'll show you the next one. It starts to illustrate the idea better. So here, there we go. So there we're starting, we'll say that this happens to be the entire piece. So, I don't want to touch anything because I'm going to mess it up. But here we're starting at this initial 0 point on the rhythm, the 0 point on the pitch, and we're starting at the very beginning or 0 point on the accompaniment. So this is this is coming from the scaffold, and this is coming from the functions. These are just representations of the rhythm function and the pitch function. And so you can see as I scroll through this, the arrows on the bottom are moving to get the particular rhythm information at that time, and then deliver the accompaniment note. So does that help? Like, it kind of explains why what you said. I think like it has a possibility of working, but once you start deviating, it's going to be a little bit harder because we're taking this from that piece that you had gotten ready for, and then you're like, okay, well, the accompaniment was good for this last part, but maybe it won't be great for the next part. But the reason it's hard is because it's taking this instantaneous information, and when you put all those eighth notes together, it starts to look something like that.
Oh, I see. So you're actually creating the accompaniment with a whole bunch of eighth notes, and then doing almost a second pass and combining them.
Right.
If they're the same pitch.
Yes.
Interesting.
And actually
with certain parameters, because sometimes you do have repeated the same note.
Exactly, yeah. So these output functions here, this rhythm, you have this new note threshold.
Mm-hmm.
So this is one output, this is another output, so this function has two outputs.
I see.
Which it's hairy, but the new note threshold, if you cross it, it can sound a new note, even if you are on the same pitch. Now, if the pitch is like, hey, I want to play a different note here, the pitch network overrides the rhythm, and so it will play. So the rhythm will sound there even sometimes if you don't have a new note.
Interesting. What about rests? For instance, one of the most interesting examples you gave was with the trombone and the trumpet.
Right.
And there's quite a bit of rest before they came in.
This is this output right here. It's the on-off, and so it has to cross this threshold to generate rest. I think I've been fighting for this in the program to make it available to the user because sometimes you know that you would like some rest there and you want it in this particular place. So it would be cool at least if you could adjust these thresholds. So yeah, depending on whatever input I gave it, I would like to say, okay, well, let's put a new note in, or let's hold off and put some rest in. Or I mean, it's not quite that simple because you're not actually putting the rest in. But if the threshold's high, you might not see it as
right.
The notes or something.
Interesting. Thank you. Cool. Well, thank you very much. We're going to hang out for another half hour, so we'll be around here till 9. But yeah, definitely hang out, ask Amy more questions, get to know each other, say hi to me if I haven't met you before, and thanks for coming. I also want to say thank you to, I don't know if there's any official NV Labs people here right now, but NV Labs is where we are right now, and they're hosting us for free, which is awesome and very much appreciated. And they also host a bunch of other really cool events every week, almost every day. They've got a whole kind of startup incubator here, and their startup companies are going to be presenting very soon and later in November. They hold lots of different meetups and events here, so it's a great space, and we're really appreciative for them hosting us tonight. So thanks again for coming and hanging out.